Hi, today we're going to walk through the Local First Development Codelab. A link to the Codelab along with other resources is in the description below. Serverless backend tools like Cloud Firestore and Cloud Functions are easy to use but can be hard to test. The Firebase Local Emulator Suite allows you to run local versions of these services on your development machine so you can develop your app quickly and safely. In this Codelab, you will run and debug a simple online shopping app which is powered by multiple Firebase services, Cloud Firestore, Firebase Hosting, and Cloud Functions. You'll connect the app to the Emulator Suite to enable local development and learn how to test the app locally. You'll need a few things to get started. First, a text editor. I'm using Visual Studio Code, but you can use your favorite editor. Second, Node.js 8.6 or higher. I can check my version by running node-version. Third, Java 7 or higher, and I can check my version by running java-version. If you're following along with the Codelab, move on to step 2 now. If you don't have a Firebase project, in the Firebase console, create a new Firebase project. I'm going to make a new project now. I'll name it Emulators Codelab. You'll notice that the project ID appears below the project name. Make a note of your project ID for later. Don't worry about analytics. We won't need that for this Codelab. In the Firebase console, navigate to the Authentication pane and then to the Sign In Method tab. Make sure the anonymous provider is enabled. For demonstration purposes, this application exclusively uses anonymous authentication. It enables you to create an onboarding experience that doesn't require users to create a permanent account immediately. In production applications, to save user data across sessions and devices, you'll want to convert users from anonymous auth to another sign-in method. In this Codelab, you start off with a version of a sample shopping web client that is nearly complete. So the first thing you need to do is clone the source code. I already have the code here. Then move into the Codelab initial state directory, where we'll work for the remainder of this Codelab. If you get stuck, you can look at Codelab final state, which contains the finished code for the whole Codelab. Now let's install the dependencies so we can run the code. The Emulator Suite is part of the Firebase Command Line Interface, or CLI for short, which can be installed on your machine using npm. I already have the CLI, and I can double-check my version by running Firebase-version. It looks like I have the latest version. This Codelab should work with version 8.4.0 or higher, but later versions include more features and bug fixes. Now we need to link this code to the Firebase project. First, run Firebase login to log into the Firebase CLI. I'm already logged in. Next, run Firebase use --add with your project ID to create a project alias. If you're following along with the Codelab, move on to step 3 now. Now you're ready to run your app. In this section, you'll run the app locally. This means it's time to boot up the Emulator Suite. From inside the Codelab source directory, run Firebase Emulator start --import equals /seed to start the emulators and import the seed data. You should see some output like this. If this is your first time using the emulators, you may have to wait for some downloads as well. Once you see the All Emulators Ready message, the app is ready to use. So, what just happened? Each of the 3 emulators we'll be using started up on your machine, and each one is running on a different port. The Firestore emulator imported data from the C directory, which is provided to make this Codelab simpler. The Functions emulator noticed the calculate cart function. That's in the Functions folder that we cloned down, and it notified the Firestore emulator because this function has Firestore triggers. The Functions emulator is now watching the Functions directory for code changes. One advantage of developing using emulators is that your changes are applied instantly. As you change code, the emulators will see the changes and update. No need to deploy or restart anything between tests. If we look in the terminal logs, we can see that the Cloud Firestore emulator is serving web traffic on the port 8080 according to this line. The first thing we want to do is connect our front-end code to the emulator rather than to production. Open the public.js homepage.js file and find the onDocumentReady function. You can see that the function accesses the standard Firestore instance. Let's update the DB object to point to the Firestore emulator. Now, when the app is running on localhost, served by the hosting emulator, the Firestore client will talk to the local emulator rather than to the production database. This means all the data will stay on my machine. In your web browser, go to localhost 4000. You should see the Emulator Suite UI. This is a local console that helps you see which emulators are running and browse data and logs. Click to see the UI for the Firestore emulator. Notice that the items collection already contains data. This is the data that was imported with the -- import flag. If you're following along with the Codelab, move on to step 4 now. In a new browser tab, navigate to localhost 5000 and you should see the web app running locally on your machine. Pick an item from the home page and click Add to Cart. Unfortunately, you'll run into an error. Let's fix that bug. Because everything is running in the emulators, we can experiment and not worry about affecting real data. If you're following along with the Codelab, move on to step 5 now. Okay, let's open the Chrome Developer Console to see the error. It seems like there was an error in the Add to Cart method, so let's take a look at that. Where do we try to access something called the UID in that method, and why would it be null? The error is coming from homepage.js. Aha! We're using auth.currentUser.id, but we're not signed into the app. According to the Firebase authentication docs, when we're not signed in, auth.currentUser is null. Let's add a check for that. Now refresh the page and click Add to Cart. You should get a nicer error this time. Now, if you click Sign in the upper toolbar and then click Add to Cart again, you'll see that the cart is updated. If you're having trouble signing in, make sure you enabled anonymous authentication in the Firebase console. So we added an item to our cart, but it doesn't look like the numbers for the cart are correct at all. Don't worry, we'll fix that bug soon. First, let's deep dive into what actually happened when you added an item to your cart. If you're following along with the Codelab, move on to step 6 now. Clicking Add to Cart kicks off a chain of events that involve multiple emulators. In the Firebase CLI logs, you should see something like the following messages after you add an item to your cart. There were 4 key events that occurred to produce those logs and the UI update that you observed. Let's walk through them. We're just going to read the code here. There's no need to write anything. The carts collection contains cart documents, and each of those cart documents has a subcollection called items. When we clicked Add to Cart, a new document was added to that item subcollection. You can see this code in the Add to Cart function in the file homepage.js. Second, a cloud function was triggered. That's arrow 2 in the diagram. The cloud function calculate cart listens for any write events, those are create, update, or delete, that happen to cart items by using the onWrite trigger, which you can see in functions index.js. Third, the function will write back to Firestore via the admin SDK, which is arrow number 3 in the diagram. The calculate cart function should read all of the items in the cart and add up the total quantity and price. Then, it updates the cart document with the new totals. Because this function is running in the functions emulator, it automatically sends this write operation to the Firestore emulator. Magic. Finally, the client will read back the new value from Firestore, and that's arrow number 4 in the diagram. The web frontend is subscribed to receive updates about changes to the cart. It gets a real-time update after the cloud function writes the new total and updates the UI, as you can see in homepage.js. We just set up a fully local app that uses 3 different Firebase emulators for fully local testing. If you're following along with the Codelab, move on to step 7 now. Next, we'll write unit tests that use the Firebase emulators to debug security rules. Our web app reads and writes data, but so far we haven't really worried about security at all. Cloud Firestore uses a system called security rules to declare who has access to read and write data. The Emulator Suite is a great way to prototype these rules. In the editor, open the file firestore.rules. You'll see that we have 3 main sections in our rules. One section controls the cart documents. Another section controls the items within the carts in a subcollection. And the final section controls the global list of items available in the store. Right now, anyone can read or write data to our database, but we want to make sure that only valid operations get through and that we don't leak any sensitive information. We'll lock down all the documents and gradually add access until all the users have the access they need, but not more. Let's update the first 2 rules to deny access by setting the conditions to false. Once we do this, all reads and writes from the web app will fail, so the user experience will be pretty broken right now. You might be wondering, what if there are no match statements for an operation? What if someone tries to write to the bananas collection, for example? Rules deny by default, so we don't need to specify rules for every single thing that we don't want to allow. Every time we save this file, the Firestore emulator automatically detects the changes and updates the rules, as we can see from the log lines below. If you're following along in the Codelab, move on to step 8 now. In a new terminal tab from the directory Codelab initial state, move into the functions directory. We'll stay here for a while. Now run npm test to run the test in this directory. There's a lot of output. Let's scroll back up and see what happened. Right now, we have 4 failures. We're going to fix these one by one by fixing the security rules. If you're following along in the Codelab, move on to step 9 now. The first 2 failures test access to the shopping cart documents. They test that users can only create, update, and read their own carts, and not carts that belong to other users. The tests are in functions/test.js. We have one test that checks that users can only write to their own carts, and we have another test that checks that users can only read from their own carts. Let's make these tests pass. In the editor, open the security rules file, firestore.rules, and update the match statements for the carts collection to only allow access for the cart owner. In rules, we often use 2 objects. The request object contains data and metadata about the operation that is being attempted. If a Firebase project is using Firebase authentication, the request.auth object describes the user who is making the request. So for each rule, we're checking if the owner UID field of the document matches the user ID of the user sending the request. These rules look similar, but if you look carefully, there's a small difference. Some use resource and some use request.resource. Resource represents the Firestore document in question before the current request. So for a create request, resource.data is always null because the document does not yet exist. Request.resource represents the Firestore document with the changes that the user wants to write. So for a create request, request.resource contains the proposed document. If you're following along in the Codelab, move on to step 10 now. Now I'm going to rerun the test and check that the first 2 tests now pass. Great! I've now secured access to shopping carts. Let's move on to the next failing test. If you're following along with the Codelab, move on to step 11 now. Right now, although cart owners read and write to their carts, they can't read or write to individual items in their cart. That's because while owners have access to the cart document, they don't have access to the cart subcollection for items. Users not having access to the cart subcollection is a broken state. Looking at the web UI running on localhost 5000, I'll try to add something to my cart. I get a permission denied error visible from the debug console because we haven't granted users access to the item subcollection. If you're following along with the Codelab, move on to step 12 now. Looking at our test file, these two tests require that users can only add items to or read items from their own cart. So I'll write a rule that allows access if the current user has the same UID as the owner UID on the cart document. Since there's no need to specify different rules for create, update, and delete, I can use a write rule, which applies to all the requests that modify data. In the last section, we used resource to get the data, but now we use get. So what's the difference? The get in the conditional is reading a value from Firestore, in this case, the owner UID on the cart document. You can use the resource object when the required data is part of the current document. If you need data outside the current document, use a get statement like this. If you're following along with the Codelab, move on to step 13 now. Now we can rerun the test. Nice, all of our tests pass. We have one pending test, but we'll get to that in a few more steps. If you're following along with the Codelab, move on to step 14 now. Let's return to the web app and add an item to the cart. We should make sure that our test and our rules match the functionality required by the client. Unit tests don't always match reality. Okay, so it looks like it worked. We still seem to have some math errors, but our security rules are set up correctly. We just improved the security of our app, an essential step for getting ready for production. If this were a production app, we could add these tests to our continuous integration pipeline. If you're following along with the Codelab, move on to step 15 now. So far, we've focused on the front end of our web app and on the Firestore security rules, but this app also uses cloud functions to keep the user's cart up to date, so we want to test that code as well. The Emulator Suite makes it so easy to test cloud functions, even functions that use Cloud Firestore and other services. In the editor, open the test.js file again and scroll to the last test in that file. This was the test that was marked as pending. Let's enable this test by removing the .skip part of the definition. That will make it run when we run all of our tests. Now find the real Firebase Project ID constant at the top of the file and enter, you guessed it, your real Firebase Project ID. If you don't remember what this was, you can check in the Firebase console or in the Emulator Suite UI. If you're following along with the Codelab, move on to step 16 now. The tests here are a bit more complex than the ones we wrote for security rules. Let's look through the code and try to understand what it's doing. We're just going to read, no need to write anything. First, we're going to use the Firebase Admin SDK to create a cart document for an imaginary user, Alice. Next, we're going to add some items to Alice's cart, one nectarine and a grapefruit specifically. Now we're going to attach a snapshot listener to the cart document. Notice that we're not listening to the items. If our function is working correctly, adding those items will trigger the cloud function to update the cart totals, so that's what we want to observe. Finally, we want to make sure that we clean up our test when we're done, mostly by unsubscribing the snapshot listener so that it doesn't get triggered again. If you're following along with the Codelab, move on to step 17 now. Now run the test again. This time you'll see all 5 tests running and the last one will fail. So the test times out because it's waiting for something to happen that never happens. We'll need to write a cloud function that makes this test pass. If you're following along with the Codelab, move on to step 18 now. In functions index.js, some of the function is written, but it's not complete. The function runs every time an item is added to the cart. It does update the price and the item count, but it only has some hard-coded values. It always updates the price to $125.98. That can't be right. What we want to do is fetch all of the items in the cart's items subcollection, add up the prices and count the items, and update the cart document. First, let's fetch the items. Now, let's count up the prices of the items and their quantity inside of that loop. We can also add some logs to print out success or error. That way we can see what's going on inside the function. If you're following along with the Codelab, move on to step 19 now. Now let's switch back to our terminal and run these tests again. They will automatically pick up the latest code as soon as we save, so no need to do anything. Nice, they all pass. If you're following along with the Codelab, move on to step 20 now. For a final test, let's go back to our app UI and make sure it's all working. Let's add an item to the cart and see if the total updates correctly. First, let's sign out and sign back in so we have an empty cart. Then let's add something to the cart. Boom! The total and the quantity show up in the UI. It's all working like we hoped. We did a lot today. We wrote security rules, we wrote cloud functions, we tested it all, and we did it without having to deploy anything. It was all happening in the Emulator Suite. This app is ready to go. If you want to deploy this app, just run Firebase deploy and ship it. If you're new to the Firebase emulators, now you have a sense of how you can create a local first workflow for Firebase services. This Codelab, the source repository with the initial and final Codelab state, and other helpful links are in the video description. Let us know if you found this helpful, what else you'd like to know about the emulators, or if you have feature requests. For now, I'll sign off and let you fire up the emulators for your own app.